I am Mr. Tarrou. In this video, I want to show you a bunch of examples where I work through some one variable inequalities. These are going to work just like solving a one variable equation, except that when we multiply both sides by the inequality or divide by a negative number, we're going to have to change the direction of the inequality. We're also going to do some shading along the number line to give you some very quick sketches or graphs of what that's going to look like. So we're going to distribute to eliminate any parentheses if we have any. We're going to add like terms on each side of the inequality if there are any to add. Then we're going to, if we have a variable on both sides of the inequality, do some kind of addition or subtraction to get all the variables either on the left or the right. I do prefer on the left when I'm working these out as a teacher. Add or subtract away from the variable and do your last step, which is multiply or divide any remaining numbers that you have away from the variable. And this is the last step where you have to look at this as possibly being a little bit different than just solving an equation. Because again, if you multiply both sides or divide both sides of an inequality by a negative number, you're going to have to change the direction of the sign. Okay, so first example. We got 6 is greater than or equal to negative 12x. Alright, so with the x we have a negative 12. It's multiplied to the x. They're touching, so you want to undo that multiplication with division. So we're going to divide both sides by negative 12. And 6 divided by negative 12, a positive divided by a negative number is negative. So we have negative 1/2. And I'm reducing the 6 over 12 by the fact that both of these numbers can be divided by 6. So 6 divided by 6 is 1, and 12 divided by 6 is, 2. So I'm reducing the fraction. Now I'm multiplying by this negative value of 12, so I'm going to have to remember to change the direction of the inequality. And anything divided by itself is 1, and thus the x is completely isolated. This reads negative 1/2 is less than or equal to 12. If you're more comfortable with it, you can change the sides of the triangle. You can swap the sides of the inequality. I don't know why I just said triangle. And write this as x is greater than or equal to negative 1/2. Now, if you are used to graphing inequalities on a number line with the variables on the left-hand side, if you do take that inequality and swap the two sides, you will have to make sure that you change the inequality along with that movement. The inequality is open towards the x, and when I change the sides, the x and the negative 1/2, I still have the inequality opened up to the x, like it was in the previous line. Okay, well now when I graph this on the number line, we have 0, 1, and negative 1. Negative 1/2 is in between 0 and negative 1, halfway through there. So I'm going to put a closed dot because of the equal sign, and I'm going to shade. Now, if you put the variable on the right, if you keep the variable on the left-hand side, the inequality kind of points the direction as to where you shade. It's x is greater than, and it's sort of like an arrow pointing to the right. X is greater than or equal to negative 1/2. Or you could just say, make up a value of x that is bigger than negative 1/2, like 0, or 1, or 2. Those are all to the right, so hence we're going to shade this inequality on the number line to the right. And that's how you solve that first inequality. Bam! Let's take a look at another one. Our next example is going to be 52 minus 4x is greater than or equal to 13. We do not have parentheses to get rid of. We do not have like terms to deal with. Yes, we have numerical values, but they're on different sides of the inequality. So when I say adding like terms, I'm not talking about like terms where one's on the left and one's on the right. And get variables on the same side. Well, I don't have multiple variables. I don't have some on the left and some on the right. I only have one variable. So this is just a two-step problem. We're going to add or subtract away from the variable. Now the 52 is positive. It's the 4 that's negative. So to get rid of the positive 52, I'm going to subtract both sides by 52 and get negative 4x is greater than or equal to, okay, now this is a positive number and this is a negative number. So we're going to subtract and keep the sign of the largest number. 52 minus 10 is 42, and 42 minus 3 is 39. So it's going to be negative 39, keeping the sign of the larger number, at least in absolute value terms. Now I want to get the negative 4 away from the x, so I'm going to divide both sides by negative 4. That dividing by that negative number is going to force me to remember, or I need to remember, to change the direction of that inequality. So we have x is less than or equal to, dividing or changing the direction of the sign because I'm dividing by a negative number. When you divide two negatives, you get a positive answer, so we have 39 over 4. Now, how many 4s are in 39? Your teacher might be happy with you leaving this in an improper fraction, but let's make it a mixed fraction. How many 4s are in 39? Well, how about 4 times 9 is 36, so there's 9 4s, and 9 times 4 is 36, but yet this is 9, so I have a remainder of 3, so it's 9 and 3/4. Okay, so we have x is less than or equal to 9 and 3/4, and on the number line, where we have 0, and out here we have a 9 somewhere, and then 10. 9 and 3/4, 9 and 3/4 is just shy of the 10. I'm closing my dot in because of the equal sign, and it's less than, so I'm going to shade this to the left, and bam! I'm done. My two-step inequality, including a graph at the end. Okay. Let's take a look at this problem. We have 4 parentheses, m minus 4 plus 7 is less than 20. Okay, I have parentheses I need to get rid of. So I'm going to distribute the 4 through the parentheses, giving me 4m minus 16 plus 7. That's not inside the parentheses, so I'm not going to multiply it by 4. And that's less than 20. I have like terms on the left-hand side that can be combined. So I'm going to bring those together and get 4m, negative 16 and 7. 16 minus 7 is 9. And in absolute value terms, 16 is the larger number, and it's negative. So it's going to be negative 9 is less than 20. Going to move the 9 over to the other side of the inequality with addition to undo that subtraction. 4m is less than 29. I'm going to undo this multiplication of 4 by dividing by 4. And we have m is less than, now, how many 4s are in 29? Well, 4 times 7 is 28. And if I have 28 but this is 29, that leaves me with a remainder of 1. So it's 7 and 1/4 is a mixed fraction. And to graph this on the number line, we have 0, we've got, let's say, 7 and 8. Kind of being lazy about my labeling of the inequality of the number line there, not doing all the tick numbers. But 7 1/4, it's a little bigger than 7 and not quite 8. I also do not have an equal sign, so I'm going to do an open dot just past the 7 and shade to the left because it is m is less than 7 1/4. Or I want to shade the number line representing all of the values that are smaller than 7 1/4, and those are all to the left. So there you go. An inequality where you have an absolute, a set of parentheses to get rid of, using the distributive property. Alrighty, let's take a look at what we have next. Each time I do an example, I'm going to get just slightly more difficult. So we have 3x. I'm doing a lot of examples, that's why this video is so long, by the way. Plus 5 times 2 plus x equals 7 plus 4x. I actually have 6 more examples I'd like to do if you'd like to watch that long. If not, just skip ahead. We have parentheses, we want to get rid of it. So we have 3x plus 10 plus 5x equals 7 plus 4x, multiplying through those parentheses to get rid of them. I have like terms on the left-hand side. I have a 3x and a 5x. So those are going to come together with addition, of course, because they're both positive. And 3 and 5 make 8x plus 10 equals 7 plus 4x. Oh, excuse me. not equals. I want to solve inequalities, not equations. This should be less than. Okay, I have a variable on the left and a variable on the right. I need to get those variables on the same side of the equation. So I'm going to pick one and move it. It doesn't really matter. With inequalities especially, I like to keep my variables on the left-hand side. Makes it a little bit more consistent on your shading on the number line. So we have a subtraction of 4 on both sides to undo that addition of 4. And we get 4x plus 10 is less than 7. Subtract both sides by 10. That's going to give us 4x is less than negative 3. You keep the sign of the larger number when your signs are different. 10 minus 7 is 3. Absolute value of the largest number is 10. It's negative, negative 3. And we want to undo this multiplication of 4 by dividing by 4. And we get x is less than negative 3/4. Now, where is that on the number line? Well, I ran out of space. Let's put it here. So we have a number line with 0 and negative 1. Kind of giving you a hint where it's at, right? Negative 3/4. It's negative 0.75 if you divide it in your calculator. So we're between 0 and negative 1, and we're about right there. Why am I putting that open dot there, not a closed one? Because there's no equal sign. Where is x less than negative 3/4? To the left. So as you go to the left of the number line, your values get smaller, and that is a little bit of a long problem there with our inequality. So bam! Let's go on to the next one. Okay, let's take a look at this question. We have 5x plus 13 is greater than negative 5 times negative x plus 5. Okay, we have parentheses. Let's get rid of them. Take the negative 5 and multiply it through. That's going to give us 5x plus 13 is greater than negative times a negative is positive, so 5x, and negative times positive is negative 25. Our x's are on, we have an x on each side, so we're going to try and use addition or subtraction to get the variables together on the same side. So I'm going to take this positive 5x, subtract it from both sides, and we know, of course, that 5 minus 5 is equal to 0. So these cross out. On the left-hand side, because students don't really like it when their variables just completely disappear, a lot of students will see this and inadvertently or incorrectly write an x. Well, if you think that there should still be one there and you're like, man, they did something wrong, let me just write an x. Then you're saying that 5 minus 5 is equal to 1, because every time you write a variable there's an implied 1 value. Well, we know that 5 minus 5 is equal to 0. So if it cancels on the right-hand side, it's also going to cancel on the left-hand side. Whoops. So what we end up with, our variables are all gone, so there's really nothing left for us to do except to say, well, is 13 greater than negative 25? Well, is it? Of course it is. So what this is saying is, because the x is completely canceled out, it does not matter at all what values of x you plug in. Every time you plug in an x, they're going to cancel out anyway, and you get this statement that is true for all values of x, because 13 is always going to be bigger than negative 25. If that happened to have been a less than symbol, and where you have 13 is never less than negative 25, then instead of being many or all solutions, it would be none. Okay? So sometimes with inequalities, you will have these problems where there's simply no solution, or like the first time I did the example, all the numbers you could possibly plug in for x are a solution, all real numbers. Our next example, we're going to have a compound inequality, where we're doing one question, but it's got two inequality symbols in the same problem. Now, with this one having an or symbol in between where, I want an x value that satisfies either the first inequality or the second. So let's see what that looks like. We're going to divide both sides by -4, and because we're dividing by a negative number, we're going to need to remember to, again, change the direction of that sign. So we're going to have x is less than or equal to -1. Or x, let's see, we have 7x is greater than 28, so we're going to divide both sides by 7. That's a positive number, so we don't need to change the direction of the inequality. And we get x is greater than 4. Now, on the number line, we've got 0, -1, 1, 2, 3, 4, 5, and x is less than or equal to -1. So that's going to be a closed dot and shade to the left because that's where your x's are less than -1. And x is greater than 4. Now there's no equal sign again, so open dot and shade to the right. Now a number cannot be less than -1 and greater than 4 at the same time. So that's why, at least in this particular example, we still have solutions because I don't have to satisfy both of them. It's or, I only have to satisfy one. Now I can possibly sometimes have x values that satisfy both, and that would pass for the, I want to solve this, or I want a solution for this or that. But when it's just or, as long as the x value satisfies at least one of the inequalities, then it is considered a solution. And moving on to the next example. This time we're going to have and in the middle. So we have 7x is greater than -35, and x, or 5x, is less than 20. So we're going to solve each one of these. Divide by 7, and x is greater than -5. Divide this by 5, and x is less than 4. We're going to graph on a number line. So here it's 0, -1, 2, 3, 4, 5. 1, 2, 3, 4. X is greater than 5, so an open dot at 5, go to the right. X is less than 4, so open dot on 4 and go to the left. Now, the inequalities could go on forever, right? They go left and right forever, but I need a value that satisfies both of them, a value for x that makes this true and this true. Well, like if I'm over here, let's say at -6, well, that -6 is less than 4, but if I plug -6 into this equation, or inequality, excuse me, I'm going to get a false statement. So when you have the word and in the middle, you're looking for the shading that's just the overlap. So the only values that will satisfy both of those inequalities are the values that are between -4 and greater than -5 and less than 4. Two more examples. Another way of writing this compound inequality with the word and in the middle, it's not like you can turn everyone back and forth and have it the same, but you can have an inequality that actually has two inequality symbols in them. So that's going to be like this example. -8 is less than -2x, which -4, and that's less than 16. So this is another version of a compound inequality. Now, I can write this as two separate inequalities and have -8 is less than -2x minus 4, and then -2x minus 4 is less than 16, and handle it as two separate inequalities. Or I can just keep it all together, which I'm going to do, because you've just seen me do a bunch of examples of solving these type of problems. If you have a compound inequality and it is written as one statement where there's these two inequality symbols, we can still, move things away from the variable that's in our directions here, but just do it 3 times instead of only 2, because it's kind of like there's 3 parts. There's a left part, a middle, and then a right side. So we want to get the negative 4 away from the x. Well, the opposite of subtracting by 4 is adding. And we get negative 4 is less than negative 2x, less than, and 16 and 4 make 20. And then we're going to divide all of the parts by negative 2 to move it away from the x. And that's going to give us negative 4 divided by negative 2 is positive 2. Now I'm dividing by a negative number, right? And that means that you have to change the direction of the inequality. So let's do that. Negative divided by negative is positive, and so that's positive 1. And 20 divided by negative 2 is negative 10. So x is both, what? X is less than 2, and x is greater than negative 10. So on the number line, that's going to look like this. I'm just going to sketch this number line, and I'm going to put a value of 2 in and a value of negative 10. X is less than 2 means open dot on 2 and shade down. X is greater than 10 means put an open dot on negative 10 and shade to the right. And since this compound inequality, this three-part inequality, you need an x that solves this one inequality, or if you pulled it apart, it needs to solve both of those two parts. So I want only the overlap. And thus, my solutions, like as it stated, x is greater than negative 10 and less than 2, or 2 is greater than x, which is greater than negative 10. Last example, and this video is done. I hope all these examples are helping. I've done quite a lot. The lengths of a side, actually let me pause and write this down to shorten this up just a little bit. Okay, last example. The lengths of the sides of a triangle have the ratio of 2, 3, and 4. Describe the length of the shortest side of the triangle if the perimeter is less than 54. Now, it's a ratio. The sides of the triangle are in a ratio of 2 to 3 to 4. And a ratio is like a fraction. You can reduce it. If I write the ratio of, let's say, 3 to 7, well, that's 3 over 7. And maybe that's not the original fraction. Maybe the original fraction was 6 over 14. But since both of those numbers are even, it can be reduced by a factor of 2 to get down to that 3 over 7. So when they say the ratio of a triangle has, or the sides have a ratio of 2 to 3 to 4, that doesn't mean that's the actual lengths of the sides. That's basically the reduced ratio. So when we say that the perimeter of the sides of this triangle is 54, well, when you have a triangle, you have 3 sides, and they need to add up. And perimeter is the length around the entire outside of the object. Well, this triangle has sides with a ratio of 2 to 3 to 4. But again, that doesn't mean that's the actual lengths of the sides. They can all be varied by a common multiple. Maybe it's 4, 6, and 8. You can also multiply by a decimal, but I don't want to try and do that in my head. So we don't actually know the lengths of the triangle, so we apply a common multiple to each of those ratio values to allow the triangle to expand and contract depending on what the value of x is. Now, perimeter is add all the sides up, so that means that 2x plus 3x plus 4x has to remain less than 54, since that's the stated condition for the perimeter. It has to stay less than 54. So that means that we have like terms of 2, 3, and 4x, so that's going to be 9x is less than 54. Divide both sides by 9, and that means that x has to remain less than 6. So, describe the length of the shortest side. Well, the shortest side is our 2x. So, the shortest side has to remain less than 6, or 2, excuse me, I lost my place there for a second. 2 times 6, or 12 units. So the shortest If the entire perimeter is to be less than 54, then the shortest side has to be less than 12 units long. I'm Mr. Tarrou. Thank you for watching these many examples. I hope you found them helpful. Bam! Go do your homework.